Welcome to our latest video on the topic of alcohols. This video is suitable for GCSE students. By the end of this video lesson, you should be able to name and draw structural formulae for the first 5 members of the alcohol family. You should also be able to explain how ethanol can be made from sugars using yeast in a process called fermentation. And you should be aware of the uses of ethanol as a fuel in alcoholic drinks and as solvents. You should also understand social, economic and environmental impacts of these uses. Alcohols are another important family of organic compounds, just like alkanes and alkenes, which we studied previously. Alcohols have an OH functional group. Now, a functional group is the part of a molecule that determines its chemical reactions. In alkenes, the functional group is the carbon-carbon double bond, because alkenes undergo addition reactions because of this double bond. In an alcohol, the functional group is the OH group. Now, alcohols have the general formula CnH2n plus 1 OH. And the first 2 members of the alcohol family are shown here with their structural formula. Now, rather than drawing them out in full, I could also write the structural formula as CH3OH, because that clearly shows that my compound is an alcohol with an OH group bonded to a CH3. And when I'm drawing ethanol, I could draw it out in full, drawing all the bonds. That's the full structural formula. Or I could shorten this structural formula to C2H5OH, which clearly shows it's an alcohol because it's got an OH group, and the OH group is bonded to C2H5. Now, the molecular formula is the number of carbons, hydrogens, and oxygens. So methanol has 1 carbon, 4 hydrogens and an oxygen for its molecular formula, and ethanol has 2 carbons, 6 hydrogens and 1 oxygen for its molecular formula. Now, the system for naming alcohols is very similar to the system we've seen previously for naming alkanes and alkenes. The first part of the word, the meth bit, the F bit, the prop, the but, the pent, the hex, this tells us the number of carbons present in the alcohol. So if you have an alcohol with 1 carbon, it starts with METH. And if you have an alcohol with 4 carbons, it starts with BUT. Now, when you're naming an alkane or an alkene, the second part of the word is either ane or ene. Now, in an alcohol, alcohols end in ANOL, anol. So therefore, an alcohol with 5 carbons is called pent, anol, pentanol. An alcohol with 4 carbons is called butanol. An alcohol with 3 carbons is called propanol. So now we've shown you the structural formula for the first 2 members of the alcohol family, methanol and ethanol. We'd like you to have a go at drawing the structural formula for the next 3 members of the family. Propanol has 3 carbons, butanol has 4 carbons, and pentanol has 5 carbons. So pause the video and have a go at drawing the structural formula of an alcohol with 3 carbons, propanol, an alcohol with 4 carbons, butanol, and an alcohol with 5 carbons, pentanol. Pause the video, draw them out, and then we'll go for the answers. So we started with methanol and ethanol, and the next member of the alcohol family has 3 carbons and is propanol. So I'm going to draw 3 carbons in a chain, and I'm going to put the OH at the end of the chain, and then I'm going to put in the hydrogens so that each carbon has a total of 4 bonds. Now, you'll notice that I didn't draw a bond between the O and the H. You can do, but most chemists don't bother with this. So I'm going to count them up, and I'm going to check that every carbon has 4 bonds, and then I'm going to number the carbons, and I'm going to start nearer the OH group. So carbon 1 is next to the OH group. Now this is important because there's two versions of an alcohol with 3 carbons in it. There's one where the OH group is attached to carbon 1, and that's called propan-1-ol. And there's another version that I can draw where I put the OH in the middle of the carbon chain. Now, if I number the carbons starting nearest the end, nearest the OH group, it doesn't matter which way I number them. I can number them left to right or right to left. So I'll number them 1, 2, 3, left to right. The OH group is on carbon 2, and this compound is called propan-2-ol. Now these different versions of an alcohol with 3 carbons in it are called isomers because they have the same molecular formula, C3, H8 and O, and they have different structures, different arrangement of atoms, different structural formulae. So now let's look at the next member of the alcohol family. Now an alcohol with 4 carbons in is called butanol. So I'm going to draw a alcohol now that has 4 carbons in, and I'm going to put the OH at the end of the carbon chain. So I'm going to put all my hydrogens in, and I'm going to make sure that each carbon has 4 bonds. Now once again, I don't bother putting the bond between the O and the H because most chemists don't do that. And I'm going to number the carbons, and I always number them nearest to the OH group. So I start this time on the right hand side because that's nearest the OH group, and you can see that the OH group is on carbon 1. So this is called butan-1-ol. So I'm now going to draw another chain of 4 carbons, and I'm going to put an OH group on a different carbon. So once again, I'm going to put in the hydrogens, checking that each carbon has the right number of bonds, checking each carbon has 4 bonds. And this time, I'm going to number the carbons. And remember, when you name an alcohol, you number the carbons starting at the end of the chain that is closest to the OH group. So if I numbered it 1, 2, 3, 4 in red here, right, the OH would be on carbon 3. But if I numbered it left to right, it's on carbon 2. Now the rule is you always number the chain nearest to the OH group. So left to right is the appropriate way of numbering. So the OH group is on carbon 2. So that compound is called butan-2-ol. Now if I move the OH along to the right, it would still be butan-2-ol because the appropriate way of numbering would be right to left. So if we look at this now, our molecular formula is C4H10O. Both butan-1-ol and butan-2-ol have the same number of carbons, hydrogens and oxygens, but they have different structures. They're isomers. So I'm now going to draw an alcohol that has a chain of 5 carbons. And I'm going to put the OH on the end like I've done previously. And I'm going to put in all the hydrogens, making sure that each carbon has 4 bonds. Now once I put the hydrogens in, I'm going to number the chain. And the rule for numbering the chain is I must start at the end nearest the OH group. So carbon 1 is next door to the OH group, and I'm going to number right to left. Now because the OH group is on carbon 1, this alcohol is called pentan-1-ol. Now if I draw a 5-chain alcohol and put the OH group on a different carbon, so I'm going to do that now. This time I'm going to put it on the next one along. So I put in the hydrogens, make sure each carbon has 4 bonds, and once again I number the chain so that I start nearest the OH group. So I start on the right and I number it right to left. This time the OH is on carbon 2, and it's called pentanol. Now, it's actually another version of an alcohol with a chain of 5 carbons, because I can put the OH group in the middle. And if I do that, putting in all the hydrogens and checking that each carbon has 4 bonds, I can then number either left to right or right to left. It doesn't matter, because if I number it right to left, the OH group is on carbon 3, and if I number it left to right, it's on carbon 3. So this alcohol is called pentanol. Now, in all of these examples, I've moved the OH to a different position. Now, the OH is a functional group. If you move a functional group to a different position on the chain, it's an isomer, and it's actually classed as a positional isomer. So pentan-1-ol, pentan-2-ol, pentan-3-ol are positional isomers, and they all have the molecular formula C5H12O. So now that we've looked at the structural formula of alcohols and how we name them, we're now going to move on and look at how we make alcohols. Now, alcohol can be made in a process called fermentation. Anaerobic respiration in microorganisms such as yeast is used in wine making and bread making, and anaerobic respiration takes place in the absence of oxygen. So these microorganisms are able to respire without oxygen, and we make use of this to make alcohol. Now, this process is called fermentation, and in fermentation the yeast converts glucose, it converts sugars, into carbon dioxide and alcohol. And the alcohol that's produced in fermentation when you use glucose is ethanol. So this picture summarizes the process. Sugar, with the help of yeast, in the absence of oxygen, makes carbon dioxide and alcohol. And the alcohol we're going to make is ethanol. Now, the alcohol that you produce in fermentation can be obtained from the reaction mixture by using distillation. And the yeast contains enzymes which speed up this fermentation process. And the enzymes are catalysts produced by living cells. And enzymes are being increasingly used by chemists to speed up chemical reactions. Now, this form of science is called biotechnology. So if we look at the equation here, we have glucose, our sugar, being converted by the yeast. And remember, yeast is a fungus that contains an enzyme which speeds up this fermentation process, and it changes to ethanol and carbon dioxide. So we have C6H12O6, and it goes to 2C2H5OH, 2 molecules of ethanol, and 2 carbon dioxide molecules. Now, this slide shows the apparatus you would use to carry out a fermentation experiment. It also shows the conditions needed. Now, to carry out a fermentation experiment, you need a glucose solution. You need glucose mixed with water. You also need yeast, because yeast contains the enzyme that speeds up fermentation. And remember, yeast is a microorganism that is able to respire anaerobically. And it's the respiration process that produces alcohol in the form of ethanol and carbon dioxide. You also need a warm temperature, around about between 25 and 35 degrees C. And finally, you need a pH of between about 4 and 7. And if you have these conditions, these are the optimum conditions for fermentation to take place. Now, during fermentation, carbon dioxide gas is also produced along with ethanol. And therefore, you could measure the volume of this gas during the experiment using a gas syringe. Now, the apparatus on the right is what you would use to measure the volume of gas produced by fermentation, and a very common experiment is to change the conditions and see the effect on the volume of gas being produced. So for example, you could change the temperature here. You could have 20 degrees, 25, 30, 35, 40, 45, 50, and you can measure the volume of gas. Now, temperature is crucial for fermentation because fermentation relies on enzymes. And at low temperatures, enzymes are inactive, they don't work very well. And at high temperature, because an enzyme is a protein, it unravels, it becomes denatured. So therefore, fermentation works best between around 25 degrees C and 35 degrees C. And if you go a much higher temperature than that, the protein will denature, will unravel. And you go at a much lower temperature, the enzyme's inactive. So that's why temperature is really crucial. Now, fermentation often takes a couple of weeks, and after the fermentation process, you have to remove the yeast. So the yeast has to be filtered, and to get the alcohol, you distill the reaction mixture. And that's why you may have heard that alcohol is made in a distillery, because distillation is a key part of the production of making alcohol. Now, fermentation is a batch process rather than a continuous process. And in a batch process, we have a sample of sugars, a batch of sugars, that are fermented in the right conditions with yeast, a temperature around about 30 degrees C, an absence of oxygen, a pH between 4 to 7, and they're left to ferment over the few weeks. And once they've fermented and made our alcohol, the process then starts all over again. So it's a stop-start process. Now, an alternative to fermentation is to make alcohol from alkenes. And this is a continuous process. I can make alcohol this way 24 hours a day. And the alkene is reacted with steam under high pressure and temperature, and you get an alcohol. Now, an advantage of making alcohol from alkenes, as I said, is it's a continuous process. So you are able to make alcohol 24 hours a day, and economically that's very good if you're running a business to produce alcohol. But a disadvantage is you're making the alcohol from crude oil, because alkenes come from crude oil, and crude oil is a non-renewable resource. In contrast, making alcohol through fermentation of sugars is a renewable process, because sugarcane is grown to produce sugar, and once you've cut it down to make your alcohol, you can just plant some more. So it's a renewable resource. It's not a non-renewable resource like oil, which takes millions of years to form. So we're now going to turn our attention to the uses of alcohol, and specifically the uses of ethanol. Now, you need to know for the exam that ethanol is used in alcoholic drinks, is used as a solvent, and it's used as a fuel. Now, this slide shows the different amount of ethanol, alcohol, that's present in popular drinks. Now, the idea of counting alcohol units was introduced in the UK in 1987 to help people keep track of their drinking. And units are a very simple way of expressing the quantity of pure ethanol in a drink, because 1 unit equals 10 milliliters or centimeters cubed of ethanol. Now, it's recommended that both males and females do not consume more than 14 units of alcohol a week. That is the healthy limit. That is the recommended limit. And this has changed recently, because previously it was 21 units for a male and 14 units for a female. However, the new healthy limits are 14 units a week for both males and females. Now, even though drinking small amounts of alcohol has found to have positive health benefits, such as being good for your heart, alcohol misuse causes serious damage to your health. It can cause heart disease, high blood pressure, liver damage, strokes, and other serious health conditions. And this slide illustrates some of these. Now at GCSE, you should also be aware of the social problems that are caused by either drinking an excessive amount of alcohol in a short period of time, binge drinking, or misuse of alcohol over a long period of time. And the social problems and antisocial behaviour you should be aware of are things like drink driving and associated road accidents, domestic violence, aggressive behaviour, argumentative behaviour, the increased likelihood of relationship breakups. It's important to be aware of both social problems and health problems when discussing the use of ethanol in alcoholic drinks. In addition to understanding the health problems and social problems caused by misuse of alcohol, you should also be aware of the economic importance of alcohol. Tax raised from the sale of alcoholic drinks generates significant revenue for the government, and this can be used to fund public services such as schools and hospitals. On the other hand, a significant amount of public money is spent each year in treating alcohol-related illnesses and in dealing with various other issues resulting from alcohol abuse. Now, in addition to the use of ethanol in alcoholic drinks, you should also be aware that ethanol is used as a solvent and as a fuel. Now, ethanol is a very good solvent as it dissolves many substances that are not soluble in water. It also evaporates quickly and is used as a solvent in glues, paints, varnishes, perfumes, printing inks and deodorants. In the exam you may be asked for a use of ethanol, and it's important that you mention that it's used as a solvent rather than saying it's used as glue or paint. Now, concern over the enhanced greenhouse effect is encouraging people to seek out alternative fuels such as biofuels, and Brazil is the leading country using ethanol as a biofuel, where plentiful sugarcane provides a renewable source and lack of oil resources mean that imported oil is expensive. Now, alcohols are often used as fuels because when you burn them, they release lots of energy. And alcohols react with oxygen on burning to produce carbon dioxide and water alongside this energy. So here's an equation to represent this. Ethanol plus oxygen goes to carbon dioxide and water. Now, the advantages of bioethanol is it's made from sugarcane, which is a plant, and it's a renewable energy source. And secondly, even though carbon dioxide is produced when the alcohol burns, and carbon dioxide is a greenhouse gas, plants take in carbon dioxide, so the process is considered to be carbon neutral. Because although you're burning ethanol, which is producing carbon dioxide, you are growing sugarcane to make the ethanol, and the sugarcane is a plant and that takes in carbon dioxide. Now, the disadvantages of using bioethanol is that it's land intensive to grow sugarcane. It takes a lot of farmland to grow sugarcane to make ethanol. And if you devote a lot of farmland to growing sugarcane, less is available to actually grow food crops to feed your population. So being land intensive is a disadvantage of bioethanol. And ethanol is less efficient than fuels such as petrol. And this means that there's less energy produced if you burn the same amount of ethanol compared to petrol. And the third disadvantage is you need a specific climate to grow sugarcane. Not every country has this climate. Now, it's very common at GCSE for students to be asked to describe the advantages and disadvantages of using bioethanol as a fuel. So now we're going to test your understanding of alcohols with some practice questions. So here's our first practice question. Read through the question, pause the video, have a go at it, and then we'll go through the answers. So now let's go for the answers to question 1. So for question 1A, give 2 conditions necessary for fermentation. So you need a glucose solution. In other words, you need to add water to the glucose because they've said in the question that they're going to give you glucose and you have to come up with the conditions necessary. So add water would be one. You also need a warm temperature between around 20 to 40. Now ideally 25 to 35 works best, but they accept it anywhere between 20 and 40. You need a lack of oxygen and you need a pH of between 4 and 7. Any two of these conditions gets you the marks. Now for part B you need to balance the equation. So you need 2 ethanol molecules and 2 carbon dioxide molecules. So if you put 2 ethanol molecules and 2 carbon dioxide molecules, you'll have a total of 6 carbons, 12 hydrogens and 6 oxygens on the right hand side. And this is balanced because I have 6 carbons, 12 hydrogens and 6 oxygens on the left hand side. Now for part C it says name the separation method used to recover the yeast. So for 1 mark they'll accept filtration, filtering or filter. For part 2, obtain ethanol from the mixture. Well, I obtain ethanol from the mixture by distillation. And then for part D it says ethanol is a biofuel alternative to petrol and is widely used in cars in Brazil. Give one advantage of using ethanol rather than petrol. So if you said it's a renewable energy resource or it's carbon neutral, that will get you a mark. The examiner will also accept if you say it reduces demand on fossil fuels. So here's question 2. Question 2 comes in 2 parts and this is the first part. So read through the question, pause the video, have a go at it, and then we'll look at part B. So here's question 2B. So the question is saying that isomers are compounds which have the same molecular formula but different structural formulae. And then it's asking you to draw the 2 positional isomers of propanol. Pause the video, have a go at it, and then we'll go for the answers. So here's the answers to question 2. So start with 2A. It says give the general formula for members of the alcohol family. So the general formula is CN H2N plus 1 OH, or they'll accept CN H2N plus 2 O. Either's fine and you don't need the brackets. That's not compulsory either. So there's 1 mark for that. So here's the answer to question 2. Propanol has 2 isomers. Draw the 2 positional isomers of propanol. So the 2 isomers are propan 1-ol and propan 2-ol. Remember, positional isomers are where you move the functional group to a different position on the carbon chain, and the functional group is the OH group. So if I put the OH group on the end carbon, that is propan 1-ol, and if I put it on the middle carbon, that is propan 2-ol. And if you drew those isomers, you get a mark for each. So here's our last question, and this question has parts A, B, C and D, and this slide has parts A and B. Read through the question, pause the video, have a go at it, and then we'll look at parts C and D. So here's parts C and D. So part C is asking you to name the compounds formed by the combustion of ethanol. And then part D is asking you to suggest 2 advantages and disadvantages of using bioethanol made from sugarcane as a fuel. Read through the question, pause the video, have a go at it, and then we'll go for the answers. So now let's go for the answers to part A and B. So part A is asking what must be added to the sugar solution to make it ferment. Well, if you said yeast, you get 1 mark. And it says circle the most suitable temperature for fermentation. So that would be 30 degrees C, and there's 1 mark for that. And for parts C and D, the compounds formed by the combustion of ethanol are carbon dioxide and water, 1 mark each for these. And it says suggest 2 advantages and 2 disadvantages of using bioethanol made from sugarcane as a fuel. So the advantages are it's a renewable source of energy and it's carbon neutral. So there's 1 mark each for the advantages, so a total of 2 marks. And the disadvantages are that it's land intensive to grow sugarcane, and the ethanol that is produced from sugarcane is not as efficient as fuels such as petrol, because less energy is given out per gram of fuel. So if you said it's land intensive and it's not as efficient, there's a mark each for that. So there's a total of 4 marks for the advantages and disadvantages. That concludes our video lesson. So after watching this video, you should now be able to name and draw structural formulae for the first 5 members of the alcohol family. You should also be able to explain how ethanol can be made from sugars using yeast in a process called fermentation, and be aware of the uses of ethanol as a fuel, in alcoholic drinks and as solvents. You should also understand social, economic and environmental impacts of these uses. So that concludes our video. Please check out our YouTube channel, Dr. O Chemistry, and our Twitter site, which contains lots of chemistry information and links, @RadaChemistry.